6 to the 3x plus 5 power equal to 1, and we're trying to solve for the variable x. Well, a lot of people are going to look at this and they're going to be, well, I just don't know where to start. But if you don't know how to solve this equation, I'm going to show you exactly how to solve this equation. But first, I'm going to give you an opportunity for you to solve this. Now, you don't even need a calculator to solve this equation, but feel free to use one if you think that's going to help you out. But if you could do this, go ahead and put your answer into the comment section. Then, of course, I'm going to fully explain exactly how to solve this type of equation in algebra. This is extremely important stuff. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And it really is my true passion to try to make learning math as easy as possible. So if you need assistance in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. Well, let's go ahead and get into it. And I'm going to do like a quick crash course here on solving these type of equations. And again, in algebra, we have different types of equations. But when we're trying to solve for the variable, when the variable is an exponent, of course, we have a power here. What we have here is an exponential equation. So I'm going to go ahead and solve a basic exponential equation, something a little simpler than this problem. Let's take a look at this problem right here. We have 4 to the y power is equal to 10. Now again, the variable that we're trying to solve for is in the exponent, just like this equation right here. So let's go ahead and just take a quick look at how we would solve something like this. So 4 to the y power is equal to 10. Again, when the variable that you're trying to solve for is in the exponent, and let's just quickly review the parts of a power. So if I have like 2 to the 5th power, right? 2 is the base, and 5, this little number up at the top right, is the exponent. The entire thing is a power. Okay, so how do we solve this type of equation? Well, this is a great question because you might be saying, well, what does this even mean? Well, it means 4 to some power is equal to 10. Okay, now the power is what we're looking for. So a variable y is just representing the answer. So let's just kind of think about this here. So if y was equal to 1, in other words, let's just go ahead and see if y was equal to 1. What is that equal to? Well, 4, that would be 4 to the first power. That's equal to 4. But I want 4 to some power such that that is equal to 10. So we're like, all right, well, that's not enough, right? I want 10, not 4. So let's increase this 1. So maybe let's go 2. So 4 squared, well, 4 squared is 4 times 4, that's 16. Well, that's too much, right? So 4 squared, again, is 16. 4 to the first is 4. So 4 to the what power is 10? So, logic tells us that, well, it's got to be somewhere between 1 and 2, right? So maybe like 1.5, something like that. And one could use kind of a trial and error method and take various powers of 4, until you get closer to finding what power, what exponent works to get to 10. But that's kind of an unscientific approach. So to solve these type of equations in algebra, you need to understand something called logarithms. Okay, so let's go ahead and talk about this real quick. So we have 4 to the y power is equal to 10. Again, this is an exponential equation. So the main thing that you have to understand is the following. When you have an exponential equation like this right here, we need to use logarithms to solve. Now, if you never heard of logarithms, if you look on your scientific calculator, you'll see a key, an log key like this, or this key right here. This is ln. These two buttons have to do with this extremely important topic in algebra called logarithms. Okay, so if you've never heard of this stuff before, I'll give you a quick crash course, but here is the main idea. When you see an exponential equation, we need to use logarithms to solve. I'll show you exactly how to solve this equation in 1 second. But when we have a logarithmic equation, we need to use exponents to solve. So in other words, if we have like log x plus 2 is equal to 7, something like this, we need to be thinking in terms of exponents or powers and exponents. Now, why is that? Well, this is because Logarithmic and exponential functions are inverse functions of one another. Okay. Now, if you're like confused with this, well, it's possible that you have not yet learned this in mathematics. This is typically a subject or a topic that is taught in like second year algebra. So if you're like in first year algebra, you probably have not yet studied logarithms, but they will be coming down the pike. But stick with me anyways, because I think you'll understand the basics of this. But let's go ahead and continue on. How do we solve this equation? Well, we have an exponential equation. We need to use logarithms, but what is a logarithm? Well, let's talk about that right now. Now, this is one of my favorite sayings to say when teaching about logarithms, and that is bacon and eggs. Yes, indeed, I said that right. So here's a plate, and you have some green bacon, I guess, and some eggs, like so. So bacon and eggs. You're like, okay, Mr. YouTube Math Man, you lost your mind. What are you talking about? Well, I'm talking about the following. So when you talk about a logarithm, I want you to just remember bacon and eggs, okay? Now, what does that mean? Well, BA equals E. I want you to remember BA equals E. And of course, a little mnemonic there, a little memory aid is bacon and eggs. So log BA equals E. All right, now what does that mean? Well, let's go ahead and talk about that right now. Okay, so before I explain this bacon and eggs business, let's go ahead and just review something about powers and exponents, and pretty much all of you out there understand it. So if I have 2 to the 4th power, what does that mean? Well, 2 to the 4th power means take 2 and multiply it by itself for 4 times, right? So 2 times 2 times 2 times 2 is 16. Okay, so we all understand that. But 2 to the 4th power, remember we have these parts of the power. So 2, this 2 right here, is the base, this 4 is the exponent, and this 16 is the answer. So when we take a certain base and raise that base to a certain exponent, okay, a certain power, we end up with some sort of answer. So we can kind of think of that situation this way. A base to an exponent is equal to an answer. And this is kind of going to be related to our bacon and eggs. All right, now remember exponential functions or things or exponential expressions, things that we can write as a power, we can express these same things as a logarithm using this bacon and eggs concept, okay? So all we're going to do is just shuffle things around. So we have log, b is the base, this number in front of the logarithm is the answer, and this is going to be equal to the exponent. So let's go ahead and take this example right here. 2 to the 4th power is equal to 16. I could write this using a logarithm this way. Log base 2, because here is my 2, and it matches my b, right? B, A, and E. We're just going to follow this pattern. So the base is 2, so I'm going to write a 2 right there. The answer is 16, and then the exponent is 4. So log 2, 16 is equal to 4. And if you were given a question like this, on a, an algebra quiz or exam, it says, well, write this as an exponent. You would just write it this way, right? So you would understand, okay, bacon and eggs. Again, what we have here is a relationship between writing powers and exponents. We can write these same things as a logarithm, and you got to be able to switch back and forth between the two. Okay, so let's go and take the next step, which of course is having you to quickly subscribe to my YouTube channel. I've got a lot more here to cover, but making these videos is a labor of love. I love teaching mathematics, but really what I love about teaching math is helping people learn math, especially people who get confused. We're talking about a topic that can be very confusing, logarithms and exponential functions. And if you're not really taught this correctly or taught with enough comprehensive instruction, people are going to be lost and they're going to think to themselves, I'm bad at math. I don't understand this. I hate math. I don't want to do math, etc., etc. Well, that's not the case, all right? So if you want to be successful in math, there's 2 things really that you need. One, you need to work. There are no shortcuts. There is a lot of material to study and learn. So if you're looking for little like tricks and shortcuts and I don't want to put the time in, well, just understand, especially if you're taking more advanced mathematics, you're going to struggle. Just too much information. So be willing to do the work. Now, if you're willing to do the work, what you need is great comprehensive instruction. And if you don't have a teacher that delivers that type of instruction to you, or you don't have an access to a teacher like that, I would love nothing more to be your teacher, but I need your support. So please hit that subscribe button. It's like I just gained a new student. And if you're going to do that, make sure to hit that notification bell as well. All right, so let's get back to understanding how to solve an exponential equation. All right, so we have 4 to the y power is equal to 10. So we have to, really first identify what type of equation we're dealing with in algebra. There's all different types of equations. So you're saying, oh, where's the variable at? Well, the variable's in exponent location. So this is an exponential equation. So we're going to use logarithms to solve. And now that you have an understanding of what a logarithm is, what do we do? Okay, so here is how you solve a exponential equation using logarithms. So this is a big topic. We're going to just take a look at a simple example. Now, first things first, is you need to have your equation written in such a way where you have just one power on one side of the equation equaling one number on the other side. Now, if it's not in that manner, so for example, if I have like 4y plus 7 is equal to 11, here, I'm not ready yet to take the log of both sides. I'm going to be taking the logarithm both sides, so I would have to clean this up and just subtract 7 from both sides. And there's a lot of additional steps you can take, but we're just taking a look at a simple example. But let's suppose we have a power here equal to a number. Okay, now, as we talked about, we have this bacon and egg situation. So we can write this as a logarithm, but that's not what we're going to do. What we're going to do is take the log of both sides, and we're going to be using this function on our calculator. Okay, this is really critical for you to understand. You do need, for the most part, access to a calculator or some sort of table to solve exponential equations, but sometimes you do not, and you'll see how this plays out in just one second. All right, but what do we do here? Well, what we're going to do is take the log of both sides. Okay, so log for y is equal to log 10, and then we're going to do the following, okay? So we are looking to solve for the variable y. Well, we have various properties of logarithms, basically different rules that we can apply when we are taking a logarithm of something, and one of those is the following. When we have the log of a power, we can drop the exponent down in front of the log. So in other words, this expression right here, log 4 to the y power, is equivalent to the following. Okay, I can put the exponent right in front of the log. And this is a huge part of solving this problem. And again, it's basically a very important property of logarithms. Now, there's other properties of logarithms in terms of products and quotients. You need to know all of them. Change of base. Again, this is a big topic. And if you are studying this and you're like, yes, Mr. YouTube Math Man, I need to know a lot about this. Well, check out my Algebra 2 or my pre-calculus courses. You'll find links to those courses in the description. I will teach you everything you need to know about logarithms and much, much more. All right, but basically, we can drop this y in front of this log right here, and the reason why we can do that is a property of logarithms. Okay, so now we have y is equal to, or y times, excuse me, log 4 is equal to log 10. Now, I want you to recognize that log 4 and log 10 are nothing more than numbers. You can go onto your calculator if you want to do this with me right now. Go ahead and type in log 4, and you'll see some sort of decimal, and log 10, you'll see some sort of decimal. So really what we have here is just a nice, lovely linear equation. Okay, so in other words, I have y, this is some number. Let's just make up a number like 2 is equal to another number like 8. So if I had this equation, y times 2 is equal to 8, well, really we would write this way, right? 2y is equal to 8. So to solve for y, all I have to do is divide both sides of the equation by 2. So that's what we can do here. And just one quick thing as well, and again, I'm throwing in a lot of stuff here. This log has a certain base to it. When you just see log by itself, this is what we call the common logarithm. It is base 10. Okay, you'll have other problems that are base 2, base 7, can be base anything. But anyways, the log button on your calculator is taking the common logarithm, which is base 10 of a number. All right, so to solve for y, what do you think we can do? Well, all we have to do is divide both sides of the equation by log 4. That will isolate this y on the left-hand side of the equation. So that's what we have right here. So y is going to equal to log 10 divided by log 4. Now, at this point in the problem, okay, when you're solving exponential equations with logarithms, you don't want to do anything with your calculator until you get down to this stage right here. Okay. Now at this point, you can just go into your calculator and take log 10 and divide it by log 4, and you'll get a number approximately 1.66. Now let's just go back to this problem. Y is equal to approximately 1.66. Now remember, way up here, we were kind of guessing what the value would be, right? Well, 1 is not enough because we want 4 to some power. And we know that that power now is about 1.66. So 4 to the first is 4. 4 to the second is 16. So 4 to what power gives us 10? Well, it's somewhere between 1 and 2, and it's exactly around 1.66. So all this stuff now makes sense. Okay, so we kind of covered a lot, and we haven't even done the problem, but now that you understand this, doing this problem here should be straightforward. Okay, so let's get into it right now. All right, now we are solving an exponential equation. Okay, I have the one power is equal to a number. Okay, now up here, my exponent's a little more involved, but it's still just one power. I have one base. I have some sort of expression that represents the exponent is equal to a number. So at this point, I am ready to take the log or log of both sides. So let's go and do that. All right, so we're going to take the log of both sides, and then we're going to use the property of logarithms that allows us to put this whole exponent expression in front of the log. Okay, so this is just a little bit more involved version of the problem we just did. So we have 3x plus 5 times, okay, log 6 is equal to log 1. Now at this point, we know that log 6 and log 1 are values. But what we want to do here is kind of be smart about this. Let's go ahead and divide both sides of the equation by log 6. Okay, so in other words, we could use the distributive property and multiply in, if we have some sort of value, but you don't want to do that. You want to try to get rid of your logarithms as smart as you can, or put all those expressions on one side. So algebraically, we are allowed to divide both sides of the equation by anything we want. So let's divide both sides by log 6. All right, so when we do this, I have 3x plus 5 times log 6 is equal to log 1, and we'll divide both sides of the equation by log 6. And this is going to be nice because log 6 divided by log 6 is 1. Okay, so now we just have to figure out what this is equal to. Well, we have log 1 divided by log 6, so we can go into our calculator, but there are some values of logarithms that you need to know. Okay, so the log of 1, these are very common kind of values that you should understand. The log of 1 is equal to 0. Okay, you don't even need a calculator for that. This right here you should commit to memory when you are studying logarithms. But if you forgot, you can certainly go into your calculator. But if you didn't have a calculator, you should know this, and I'll show you how you can remember it in a second. So log of 1 is equal to 0. So 0 divided by a log of 6, it doesn't make a difference what log of 6 is, what decimal. 0 divided by anything is 0. Okay, so that's going to really help us out. But let's just take a quick look on why log 1 is equal to 0. Now remember, when you have an expression like a logarithm where it's just log and you don't see a number down there, that number is 10. So if you are dealing with another logarithm like log base 7, okay, x, something like that, well, this is explicitly telling this is base 7. But if you just see log by itself, it's implied that the base is 10. Again, it's called a common logarithm. So log of 1 is equal to log base 10 of 1. Again, we don't write it this way, we write it this way, but we're going to use this expression right here, or we're going to write it this way so we can kind of get back to our bacon and eggs. Remember, this is our bacon, this is our A, bacon and, so this is the base, okay, and this is the answer, and let's let this equal to some exponent, right, bacon and eggs. So I can write this as the base to an exponent is equal to the answer. So the base is 10 to some exponent, and that's equal to the answer of 1. So we have this situation right here, 10 to the x power is equal to 1. Well, what's the solution to this equation? Well, anything to the 0 power is 1. Okay, so when you have a situation like this, an exponential equation, and you have 10 to the x power is equal to 1, well, x has to be 0 because 10 to the 0 power is 1. 1,000 to the 0 power is 1. Anything pi to the 0 power it's equal to 1, so x is equal to 0. So again, you should be familiar with these kind of common logarithm values. So log of 1 is 0. We can see that. We don't even need our calculator. So all that's equal to 0. So this is going to make this problem super easy. Okay, so again, when we divide both sides of the equation here by log 6, this goes away. Log 6 by log 6 is 1. So we just have this on the left-hand side. And we have log 1 divided by log 6. I'm like, oh, this thing is 0. So this whole thing over here is going to be 0. So really now what we have is just 3x plus 5 is equal to 0. And of course we are now back to a lovely linear equation. So let's go ahead and solve for x. So what we need to do is subtract 5 from both sides of the equation. We get 3x is equal to negative 5. Now we're going to divide both sides of the equation by 3. And x is equal to negative 5/3. Okay, so, again, I covered a lot of material, but I'm kind of made the assumption that some of you out there might be new to logarithms. I hope you stuck around for the entire video. Of course, if you're listening to me right now, that's tells me that you did, because you will see logarithms, especially exponential equations, how to solve exponential equations and how to solve logarithmic equations. This is an extremely important part of mathematics. But here is the great news. The great news is you get to use a calculator these days. Way back in the good old 1970s or 60s, and even into the 80s, or at least the early 80s when I was going to school, high school learning this stuff, you had to use, well, there was calculators. In the 70s, scientific calculators basic calculators started coming out. Really, scientific calculators weren't really kind of available to the students at large until like the late 70s. Some of you might know more precisely when, but it was definitely in the 70s, and they were extremely expensive as well. But in the early 80s, not everybody had scientific calculators. But what I'm getting at is that when you study logarithms in like your Algebra 2 course or your college algebra course way back in the good old days, you used to have to look this stuff up in tables. So all the books back then, all of the math books in the 70s, 80s, 60s, and of course behind that, you didn't have your calculator, so you'd have to go in the back of the book and use tables of values, which would be a nice additional interesting part of doing a problem like this. So you should be very grateful that you're studying math during this time. So please take advantage of your calculators. Unless you really want to kind of do it old school, you have to find yourself a nice old book, or I'm sure there are still tables of values that you can look up on the internet. But anyways, hopefully this video was helpful. And if that was the case, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.